we get some pretty wild stuff set our way for these deep dives.
Oh, yeah, for sure.
But this one takes the cake, honestly.
Yeah.
You flag Light Isn't What You Think Too by Dave Champagne and 01. And I gotta say, after reading it, I totally see why it caught your eye.
It's a fascinating one, for sure.
Yeah, it's like, forget everything you thought you knew about light being, like waves or particles.
Right.
This source, it just jumps right in headfirst into this thing called motion theory.
Yeah.
Which basically says light is like this totally different thing altogether. It's like structured motion.
Right.
So in this deep dive, what we're going to try to do is like really wrap our heads around this theory, like how it's presented.
Okay.
And just see how it like flips the script on not just light, but a whole bunch of other related ideas.
Absolutely. I think this one could really change how we see things.
Yeah, for sure.
It's a truly radical perspective. And the thing that jumps out at me is like the sheer scope of its central idea. I mean, we're not just talking about like tweaking our understanding of light a little bit. Yeah. This theory is saying that everything in the universe at its most fundamental level is motion.
Like everything.
Everything.
Oh, wow.
That's a pretty profound place to start.
Yeah, that's a huge statement.
It is.
Okay, so let's break down this whole motion idea a little bit. Motion theory, it talks about raw motion versus structured motion.
Right.
So what's the difference, and where does light fit into all of this?
Okay, so think about it this way. Raw motion is kind of like the chaotic, disorganized movement you might see like in a jar full of buzzing flies or something like that.
Okay.
It's just unstable, no clear pattern.
Okay.
Now, structured motion, on the other hand, this is motion that has organization.
Okay.
It has like a repeating form or a rhythm.
Okay.
Imagine like a perfectly spinning gyroscope or, even like the consistent pulse of a heartbeat. So according to motion theory, light isn't like a separate thing traveling through space.
Right.
Light is structured motion.
Okay.
It's a rhythmic pattern of motion that's like propagating.
Okay.
And the big thing to remember here is that in this framework, it's not a particle.
Right.
It's not a wave.
Right.
Like in the way that we traditionally understand those concepts.
Yeah, that's a big shift. Okay, so if light itself is this, structured rhythmic motion, how do our eyes actually work according to this theory?
That's a great question.
Because it's so different from the idea of like light hitting our retinas as photons.
It is. Yeah. And it gets to like a core part of this theory.
Okay.
Because motion theory says our eyes aren't passive receivers.
Right.
They're not like light meters.
No.
Instead, they're active motion detectors.
Okay.
They're constantly sensing and interpreting the patterns of motion that are coming into them.
Okay.
So like when that organized motion from, let's say the sun travels across space and reaches our eyes.
Okay.
Our visual system, it detects those rhythms.
Okay.
And then it translates those rhythms into what we perceive as shape, color, brightness. It's almost as if our brains are like decoding a language.
Right.
Where motion is like the alphabet.
That's fascinating.
Yeah.
Okay, so the source you shared, it makes this pretty clear distinction between motion theory and what it calls like mainstream science, especially when it comes to UV light.
Yes.
And, its effects.
Right.
Which are usually explained by energy.
Exactly.
So can you kind of walk us through how those two explanations compare?
Sure. So mainstream science explains light in terms of photons, which are these tiny packets of energy.
Yeah.
And the energy of each photon is directly tied to its frequency.
Right.
So higher frequency light, like UV light, carries higher energy photons.
Right.
And that's why it's considered to be harmful, because these high energy photons, they can damage biological molecules.
Right.
Now, motion theory offers a totally different explanation.
Okay.
Remember, no photons here.
Okay.
What we think of as frequency is reinterpreted as rhythm density.
Rhythm density. Okay.
How tightly packed the cycles of motion are.
Okay.
So UV light is not like this stream of high energy particles hitting us.
Right.
It's structured motion with a really, really dense rhythm.
Okay, so it's not like these high energy bullets causing the problems with UV exposure.
Exactly.
So what is it in motion theory?
So instead of thinking about like energy transfer from a particle, motion theory says the problem is the high rhythm density of the UV light. This really intense, rapid rhythm can interfere with the more delicate, structured motions in our biological system.
Okay.
Think of it less like being hit by something and more like your own rhythms being overwhelmed by this like really insistent external rhythm.
Okay.
When the theory talks about energy absorption, It's not about absorbing packets of energy.
Oh.
It's about our bodies receiving these motion rhythms and responding to them.
Oh.
The harm comes from this rhythm stacking.
Rhythm stacking.
Yeah, and the pressure of this intense synchronization on our cells' own motion patterns.
Okay, so that's like a really different way of looking at it.
It is.
Okay, so the source also goes into this whole realm of quantum mechanics.
Yeah.
Which, for a lot of people is just this mind-bending weirdness.
It can be, yeah.
It suggests that motion theory can maybe give us like a more intuitive way of understanding these quantum phenomena.
Yeah, it's really interesting.
So how does the idea of structured motion help demystify the quantum world?
Okay, so mainstream quantum mechanics is famous for these concepts that seem to defy common sense,
right?
Like wave-particle duality,
right?
And the uncertainty principle.
Yeah.
Motion theory says that these things aren't like fundamental mysteries of reality,
okay,
but they're actually natural outcomes of how structured motion behaves,
okay,
under certain conditions and constraints.
Okay.
Quantum states in this view.
Yeah.
Are essentially specific rhythmic patterns of motion
okay.
that are always adjusting their synchronization with their surroundings.
So it's all about how these motions are syncing up.
Exactly.
Okay. And what about some of those classic quantum experiments?
Yeah.
The source specifically talks about the quantum zeno effect.
Right.
So how does motion theory interpret that?
Well, they think their interpretation of that experiment actually offers some good support for their theory.
Okay.
The standard explanation usually involves this idea that if you observe a quantum system, you prevent it from changing.
Right.
But motion theory says that observing isn't some mystical thing that collapses a wave function.
Okay.
It's actually a process of synchronizing the rhythms of the structured motion.
Okay.
They say their data shows that when we observe, we're kind of imposing a stable rhythm on the system.
Okay.
And that prevents it from changing to a different rhythmic state.
So we're not freezing a particle,
Right.
Sinking motion.
Exactly.
Okay. So how does motion theory view the photon? Yes, the photon.
Which is like the fundamental unit of light in mainstream science.
Right.
Does it even have an equivalent in this theory, or is it just a completely different concept?
They're pretty straightforward about this.
Right.
They think the mainstream photon is incomplete.
Okay.
And kind of misleading.
Okay.
Instead, they say what we call photons are actually specific instances of structured motion rhythms that are moving at the maximum speed of synchronization.
Okay.
So things like entanglement and tunneling.
Right.
Which seem weird when you think about them as particles.
Yeah.
They're just natural outcomes of how these structured motion interactions play out.
Okay.
When they're subject to certain synchronization constraints.
Okay.
The theory is suggesting that there's an underlying order and predictability at the quantum level.
Yeah.
But we have to shift our thinking from particles to this dance of motion synchronization.
Okay. So if there are no particles of light and no waves in the traditional sense,
yeah.
What is light in its most basic form? Basically, it's continuous rhythmic structured motion.
Okay.
Moving through what they call raw motion.
Okay.
It's not a separate thing interacting with motion.
Wait.
It is motion.
Okay.
It's just a very specific kind of motion.
Yeah, okay.
That's stable, self-sustaining, and rhythmic.
Okay.
The reason we see visible light
yeah.
is that our eyes, our motion detectors, are tuned to detect a specific range of these motion rhythms.
Okay.
And that incredible speed of light, that's not some arbitrary thing.
Okay.
It's the ultimate speed limit for maintaining stable structured motion. If you try to go faster, that organized rhythm breaks down and it turns back into raw motion.
Okay, so we're starting to build this picture of light as structured motion.
Right.
So let's talk about how this applies to our everyday experiences.
Yeah.
How does motion theory explain things like the warmth of the sun, the heat, the sharp edges of shadows, or, why light seems to travel in a straight line?
All right, so this is where the explanatory power of the theory really gets interesting.
Okay.
Let's take heat, for example.
Okay.
We usually think about heat as energy transfer,
right?
Like particles colliding and increasing their kinetic energy.
Right.
But motion theory says that when the structured motion of sunlight interacts with the atomic motion in a material, it makes those atomic rhythms stronger, more vigorous.
Okay.
So this increased atomic motion, that's what we feel as heat.
So it's motion adding to motion.
Exactly.
Not particles hitting each other.
Right.
Okay,
right.
That makes sense in this framework.
Yeah.
What about the straight path that light travels?
Okay.
So why do we see those sharp shadows?
Once structured motion gets synchronized in a specific direction, it just keeps going in that direction.
Okay.
It follows its last synchronized direction.
Okay.
It only changes direction if it hits something that disrupts that synchronization pattern.
Okay.
So shadows happen when something blocks the path of these motion rhythms.
Okay.
Because the rhythms can't get through.
Yeah.
There are fewer of them reaching the area behind the object.
Right.
And that's what makes the shadow.
Okay, that makes sense.
Yeah.
What about some other things we see all the time?
Sure.
Like how strobe lights make things look jerky.
Yeah.
Or the perfect reflections we see in mirrors.
Okay.
Or how light goes right through glass.
All right, so strobe lights.
Yeah.
With their rapid on-off cycles.
Right.
They're basically giving our eyes these distinct rapid pulses of structured motion.
Okay.
So we perceive these separate bursts of rhythm as individual snapshots.
Like freeze frames.
Exactly. That's the stroboscopic effect.
Okay.
Now, mirrors,
Yeah.
they have super smooth surfaces.
Right.
So they're excellent reflectors.
Okay.
Because they let the incoming motion rhythms bounce back without messing them up.
Okay.
So we see a clear reflection.
Okay.
Glass, on the other hand,
Yeah.
is transparent because its structure allows certain motion rhythms to pass right through the rhythms that match its own resonant frequencies.
Okay.
So the light keeps its synchronization as it goes through.
Okay.
And we see an unaltered view.
So it's like the glass is vibing with the light.
You could say that.
Okay. What about color?
Oh.
So the way light bends in water.
So in this framework, colors are just our interpretation of different speeds of these motion rhythms.
Okay.
What we see as red might be a slower, less dense rhythm.
Okay.
While blue or violet could be a faster, more densely packed rhythm.
Okay.
And refraction, the way light bends in water.
Yeah.
That's because the speed of the motion rhythm changes
Okay.
as it goes from air to water.
Okay.
That change in speed makes it change direction.
Okay, so what about some of the more trippy optical effects?
Okay.
Like the colors you see in soap bubbles, or how telescopes can see so far.
Right.
Or how movie projectors create that illusion of movement.
Those are good ones. Okay, so those swirling colors and soap bubbles, they happen because of the interference of multiple motion rhythms within that thin film of soap.
Okay.
These rhythms can either add to each other or cancel each other out
Right.
at different wavelengths or rhythm densities.
Okay.
And that's what creates those vibrant shifting colors.
Okay.
Telescopes basically work by gathering and focusing those faint motion rhythms coming from distant objects.
Okay.
So by concentrating those rhythms, they make those faraway objects visible.
Okay.
And movie projectors.
Yeah.
They work by showing a bunch of slightly different stored patterns of structured motion really fast.
Okay.
Our eyes see these rapid changes as continuous movement.
So it's like a flip book for motion.
Exactly.
Okay, cool. And let's go back to that universal speed limit for light one last time.
Okay.
Why can't these motion rhythms go any faster?
So according to motion theory,
Yeah.
the speed of light isn't like a rule that's imposed on the universe.
Okay.
It's more like a built-in limit
Okay.
on how fast structured rhythm can travel and still stay organized. If it tries to go any faster,
Yeah.
the stress on that rhythm is just too much.
Okay.
It falls apart and it turns back into raw motion.
So that threshold,
Yeah,
the point where it breaks down,
exactly.
that's what we call the speed of light.
Right.
Okay. So to really sum this up,
Yeah.
motion theory is saying that everything we experience, from the simplest reflection to the craziest light show,
Right.
is really just structured motion.
Yeah.
And it's all about how our senses pick up and interpret those rhythmic patterns.
Exactly.
Reality in this view
Yeah.
isn't about particles or fields.
Right.
It's about this constant dance of structured motion,
Yeah.
syncing up and interacting.
It's a pretty radical shift in perspective.
It is. It's a huge shift.
It's taking what we think we know about the universe
Yeah.
and kind of turning it on its head.
Yeah, it's wild.
Yeah,
Well, this has been a seriously deep dive
it has.
into a totally different way of understanding not just light,
Yeah.
but reality itself. You know, all thanks to this fascinating material you brought to the table.
It's a really thought-provoking one.
It is. It really makes you think,
Yeah,
you know, and it gives you those aha moments
definitely.
as you start to see all these everyday things through this new lens of structured motion.
Right.
So I hope we've managed to unpack it all
Yeah.
in a way that makes sense,
Yeah.
you know, without making your head spin too much.
Yeah. Hopefully we've shed some light on it.
I see what you did there.
Oh, well.
So thinking about this whole idea
Yeah.
that everything might be this rhythmic motion.
Yeah.
Always syncing or getting out of sync.
Right.
It really makes you wonder what other fundamental things we think we know about the universe might be totally different when you look at them through this lens of synchronization.
Absolutely. It really opens up a whole new way of thinking.
It does. It really does give you a lot to think about.
Definitely.
So thanks for joining us for this deep dive.
Yeah, thanks for having me.
It's been great exploring this with you.
Likewise.
And for everyone listening out there, keep those minds open and keep questioning everything.
Yeah, that's the most important thing.
Absolutely.